Hi, my name is Ron Lev,
And my name is Mark Sadov.
and this is the Everything Medical Podcast.
Today we have Dr. Nagan on our podcast. She was our chemistry professor last year, and she's a distinguished professor at Stony Brook University. We're sitting down with her today to talk about the research that she has done, as well as her life as a professor and as well as a former student.
So for the first question, what personal advice from your own college experience can you give your students to help them succeed?
So this was actually advice that I got from my study partner, and that was to study for a test a week ahead of time. It was like a phenomenal idea to me. Like I think I was like the night before type of person where like I just cram a bunch of stuff in and be like, oh yeah, I get this. Like I did the homework. Let's just do like, I don't know, make some notes and be like, go over them and then do the test. And let's just say it didn't go very well. And so my friend Heather told me that, well, so we had two tests. We were taking two classes, two junior level chemistry courses at the same time. And they had tests on the same day within an hour of each other. I mean, it was like just back to back. And so
You kind of had to get used to like the curriculum and everything, right?
Yeah, because it was like two of the hardest classes that I'd ever taken in chemistry. And they both had tests on the same day. And so she was like, okay, well, normally we need to start a week ahead of time, but let's do 2 weeks ahead of time because this is hard material.
Yeah.
And so if we had one test, she would say, well, like let's say that the test was Friday. She'd say, okay, over the weekend, why don't you like start going over your stuff? I'll go over my stuff and we'll meet on Sunday and we'll go over it and figure out what we don't know. Can you imagine being ready to take the test on Sunday? Like when the test is Friday.
Yeah.
And so we'd get together Sunday and we just go over like just the topics that we didn't understand. And then we'd send one of us, like if both of us couldn't go, we'd send one of us to go see the professor on Monday.
Oh, wow, that's a good strategy. Did you
Right?
find yourself having more success when you worked alone or when you worked like studying with someone?
So that's the thing. I'm like a loner. Like I'm a total loner. I need to like work out all the work by myself.
Mm-hmm.
But what I really liked was that we had this dedicated time with somebody else, you know, so it's Heather and maybe someone else too, like, you know, in other classes. And we'd get together for maybe 3 hours on Sunday.
Wow.
You know,
Did your
we'd like make a whole list. Like, what are all the topics that are supposed to be on this test? What do you think all the topics are? I'm going to put my topics on.
and you'd
It
like
was like really thorough. Yeah, we compare, and then we'd say, "What does that professor mean by that?" You know what I mean? We and then if someone knew it, they could go over it. But a lot of times we were both stuck.
Did your study habits change throughout college?
So that was, this is so sad. This was my junior year,
Mm-hmm.
Wow.
right? Like
Yeah.
I didn't figure out how to study well until my junior year in college. I could have been such a better student overall if I had figured that out sooner.
Yeah, it takes like a lot of classes. Like some people say that it takes a lot of classes to really figure out how you study and what works for you and how you study well and everything.
Well, but so when I was in high school, this sounds really bad. I don't mean to be like egotistical. When I was in high school, everything came really easily to me. I didn't have to work very hard. I just kind of went to class and goofed off and got A's on the tests. And so I had no idea how to study. And then when I got to college, the professors were like, you need to study 2 hours for every day that you're in class. I was like, oh, they're really I don't think they know what they're talking about. I don't think they're talking about me, you know? And I tried the whole 2 hours thing, but I couldn't read the book. Reading the book for 2 hours made me fall asleep. So I was like, well, clearly the professors don't know what they're talking about. You know, but actually they did. It's just that I was studying the wrong way.
Yeah.
You know what I mean?
Mm-hmm.
Yeah, personally, I would also get like kind of bored by reading the books. I have to like for chem, for example, I have to do practice problems, and that's how I learn. I can't like read a book the whole time.
I use the book as a resource.
Mm-hmm.
Now that I'm better, I go back to the book and I say, oh, well, I didn't really understand this. I'll read just that paragraph.
Yeah.
And then it's like, oh, okay, yeah, that's better.
Yeah, like it's a good way to like reinforce what you learned in the lecture. I feel like reading. Yeah.
But like I can't read the whole chapter on water.
Yeah.
Yeah.
It's tough.
What is water? So yeah, I have to use it as a resource.
Okay, so you obviously chose to go down the path of teaching in chemistry. So what aspects of chemistry interest you the most?
So I was going to be a math major if I wasn't a chem major. And so I really like the abstract part of chemistry. Like I like imagining the chemistry happening in my head. So
So
I
like
imagine little balls,
Mhm.
like attacking each other, or like really, I like symbols. So that really speaks to me. But the first time I knew I really loved chemistry was when I took physical chemistry 2, which is quantum chemistry. And that was, I know it's crazy, right? Because it was sort of the math I really liked combined with the chemistry. And it was like a reason why you did the math. I felt like before I just did math.
So
I
okay,
just did calculus.
Yeah.
But here I could apply it to chemistry and I could solve a chemical problem. And so I thought that was cool.
definitely.
And I also liked making things.
Making things like
So
in the lab.
yeah, like in the lab. When I was in organic chemistry, like second year chemistry, I guess the first thing I did was extract. The first fun thing I did was extract caffeine from coffee. Like I made coffee and then I did some extraction techniques.
Okay.
Isolate the caffeine. You're not supposed to eat it. Just if you make it in lab. But yeah, I made a lot of things. So I did synthesis. And then my school had you do these projects. You had to come up with original projects in every upper level class you took. And that's what made me realize that science wasn't just about getting the right answer. Like I feel like when you take your classes, you get 46.4 molar, or whatever it is, whatever the answer is, you get that answer. But what I discovered through my classes was that I got to create a new project every semester. I got to discover new chemistry every semester. And that was a really fun way to think about science.
Wow.
Like, okay, so you're studying inorganic chemistry, that's metals. What metal do you want to study? What compound do you want to make? So I liked niobium. I don't
You
know
were
why.
able to.
Yeah, and so I made a proposal to make this compound, and I put hemiporphosine, this ligand I had made. It's this cool looking thing. It looks like the heme and hemoglobin without the iron, but now I wanted to put niobium in it.
Wow. So you were able to experiment and do things in the lab like that you wanted to, that you were interested in.
Yeah.
Oh, wow.
And I did that for every class I was in.
Yeah.
Yes, you have a lot of freedom.
Yeah, a freedom that I didn't think scientists had.
Yeah. So why did you decide to become a professor? Was teaching something you always wanted to do?
It was on a list, like teaching students was on a list, but I didn't know what level. I tutored algebra when I was in high school, and I was really proud because I got this kid who was like earning an F in the algebra 1 where you stretch it out over 2 years, so like he had failed algebra 1 basically, and he was taking it over 2 years, and I helped him pass. And I was really, really gratified with that experience. But I don't think I understood. So then, I was like, oh, I could be a high school teacher. But then when I went to college, my junior year going into senior year, I had a conversation with my advisor. And he said, well, what do you want to do when you finish? And I said, I don't know. I said, I really like these research projects where I just come up with ideas. And I like teaching. And he said, oh, well, if you want to come up with research projects on your own, you need a PhD. And I said, oh, like I had no clue. And so I said, well, I don't know. Will they accept me to graduate school? He said, yeah, anyone with a 3.0 GPA in sciences, no C's, and, research experience. I mean, the higher your GPA, the better, but you should have some research experience so that you can demonstrate you can do research. And he said, there's a lot of graduate schools and they pay you to go to graduate school in science.
Wait, so the school pays you to go to a graduate school in order to, like, for you to become yeah. Wow.
So what was at the top of your list if it wouldn't be a teacher?
Really? I was going to go into the Peace Corps.
The what?
The Peace Corps? I wanted to go to, I don't even know what chemists do in the Peace Corps. Maybe they teach chemistry. Maybe they help people set up pharmaceutical companies. Maybe they help water treatment plants. I wanted to go serve somewhere internationally.
Wow, that's really cool.
But then I went to graduate school. So now it's kind of a linear path. Like you go to graduate school, then sometimes you do a postdoc, and then you go get your professorship.
Okay, so if students want to become professors, what advice would you give them?
Well, first of all, you have to absolutely love the science or whatever you're getting your PhD in.
Because you're teaching it all day.
Well, because you're teaching it all day, but also the process of getting your PhD is a little grueling, quite honestly. So what drives you, what keeps you going, what makes you a good scientist in that PhD program is your passion for science and the passion for the specific science that you're doing.
So you have to be really interested and devoted to what you're researching, obviously.
You can't just be like, oh, hey, I got a 4.0 GPA and I want to go to graduate school because that's the next thing to do and they pay you to go.
Yeah.
You're not going to make it. Like, really?
No, yeah. A lot of people say that about becoming a doctor too. Like, if you don't really want it and you're just going through the steps, you're not going to make it, You got to really love what you're going to eventually do.
And on top of that, you're also teaching students. So if you don't enjoy it, you probably won't be able to teach your students well.
Yeah. So I didn't, so I was getting this PhD, and when you get your PhD and you go become a professor, there are a lot of different routes you can go. And one of them that I was interested in was teaching at a primarily undergraduate institution, which is not Stony Brook. Stony Brook is a research institution. So there's sort of two paths that you can go on. Well, actually there's three. You could go teach at a community college. So community colleges are all teaching. Stony Brook is almost all research and some teaching. And then these primarily undergraduate institutions are like 70% teaching, 30% research. So it's a different balance. So I taught chemistry for everybody class, like non-majors, poets. So I taught that class for a semester, my fourth year of graduate school, because I found somebody, they were like in an emergency situation and needed somebody. So I taught that class. And when I got in the classroom, that's when I realized like how much fun it was and how much I loved it.
Yeah.
And so I was like, oh, I'm going to do primarily undergraduate institutions. And so that's what I did for the first, 18 years of my career.
And how did you make the transition to research school like Stony Brook?
Well, honestly, it was personally driven, Adelphi, the school I was full professor at and department chair, was an hour and a half to 2 hours away from my home.
Oh, wow.
And I have 4 kids.
Yeah.
So it's pretty far, and Stony Brook had a position open. And so I was really fortunate to be able to get it. And on top of that, I kind of look at it as, before I was teaching really small classes and I got a lot of really personal interactions with like 10 people, right? And I got to teach maybe 3 of those courses. But now I'm teaching Gen Chem 2, and like the semester you took me, I had like 1,100 students.
It was a full class. I remember
Super
the
full.
first day. The first day there was nowhere to sit, and then it got freed up.
Right, in Javits 100, it was just full. That holds 570 students, and I taught that twice a day. And
Is it
And it's,
harder to teach such like a large group like that? Rather
yeah, I have to adapt because, well, first of all, I didn't used to do PowerPoints,
yeah.
right? So I used to just handwrite on the board.
Oh.
My class went at the pace of me writing on the board and talking and having sort of a conversation. We had a dialogue throughout the class, but I can't do that with 570 people in the audience. So I had to switch to PowerPoint. But then I really think that chemistry is best learned by doing it. Like you said, practicing, right? Practicing problems. And you don't know that you don't know the material until you actually try it. Because you can watch somebody do it and it seems really easy. You're like, oh yeah, I get that. But then when you try to do a problem, I don't know, it just comes out that, hey, wait a minute, how did you know how to do that step? And so you have to try it.
Yeah,
and I like to have that conversation.
I remember you had a lot of clicker questions during your lecture, and that helped me a lot. It made me realize like what I needed help with and, you know, what I knew already.
So I would say, I don't know, Ron, what you think, but I think like probably 25 minutes of our 50-minute class was clicker questions.
Yeah,
Yeah,
literally.
it was. Yeah.
Mm-hmm. That helped a lot. It was, yeah.
Yeah, so it's what they call active learning.
Mm-hmm.
Because you're engaging with the material. You're not just sitting there and absorbing it.
Mm-hmm.
You're engaging with the material and figuring out what you know and what you don't know.
Yeah. What other methods have you used to ensure your student success?
So I like to know who my students are.
Mm-hmm.
I think by knowing who they are, like Ron, you asked questions all the time. And I really appreciated it. You know, like, especially when we went online, I think you like came out of your shell. And I liked that because I felt like then you felt more free to really delve into the material and you felt comfortable asking questions that you might not have asked before. And you're paying for an education. The way I see it is you are paying to go to Stony Brook. So thousands of dollars. And so it's my job to answer your questions and help you learn the material, you know, and if you don't feel comfortable asking those questions, then, you know, you're not going to learn as much. So that's why I try to get to know people, get to know their names, you know, where they're from, what type of learner they are. You know what I mean? It's like some people are audio, some people like you to show them things. Some people just want validation that they're going about it right, or that they got the right answer, or, you know.
Yeah, definitely helped a lot. Do you believe that online learning is beneficial for students?
Depends.
Are you currently teaching an online class or no?
Yeah, I am. I'm teaching online and I'm trying to make it like my regular classroom. And I'm doing it synchronously. And that's because I think for Gen Chem 2, people are transfer students, people are freshmen, they're kind of young scientists and they don't have as much personal responsibility for their education. So watching a bunch of videos by yourself is just not always productive. I mean, if you already understand the material, right? And you're just checking off this class as like this is a requirement I have to take. And I already know the material from high school, or I already know it from other stuff, then I guess online would be efficient. But if you're actually learning this for the first time, I think being able to ask questions is important.
Yeah, definitely.
Yeah, synchronously, I think is like most of our classes are synchronous, and I think I understand the material a lot better because everything is live, and I feel like you can ask the teachers questions in real time.
Yeah.
So I've done flipped classrooms before.
What do you mean by
that? I
that?
did a flipped classroom for the dental school.
It's like half, right?
Sort of. So I made these videos. So imagine me sitting here and, you know, espousing biochemistry, you know, and I find PowerPoint slides and I go through my PowerPoint slides. There were short videos. I normally probably would have covered the material in an hour, and they were probably 10 minutes to 15 minutes long, the videos. They were pure content at breakneck pace with no pauses. And the dental students were supposed to watch them and understand every single component and read their book. And then they were supposed to come to an open classroom that was like an hour and a half long, where I had these problems that were written about dental school problems, like, or dentistry, I guess. So I learned about fluoride and why it works. And, you know, so I would talk about tooth enamel, and then I talk about the biochemistry of tooth enamel.
Wow. I'm actually
Except that, are you pre-dental?
Yeah, I'm pre-dental.
Cool. So then with students had to do these open-ended questions. So remember our workshop problems where sometimes there was like a big word problem, and then there was like blank space.
Oh,
right?
Yeah.
That's what the dental school problems were like. And it was an hour and a half of that. And then they were supposed to take quizzes. You know, but for someone more mature, that was like problem-based learning where we put everything in context of something you care about.
Yeah.
So I've done problem-based learning, I've done the flipped classroom, but I think it works really well for upper level students.
Yeah, I agree, because they're more responsible, they're more mature, they can handle it.
Okay, so now we're going to talk about some of the research that you've done. So we were going to ask, what kind of research have you done?
So my specialty is RNA structure, ribonucleic acid structure. So there's DNA, that's your genetic material. And there are proteins. Those are like the workhorses of your body. So proteins carry out a lot of functions. They transport things. They like transporting oxygen, transporting drug molecules. And then there's also enzymes. Those are catalytic proteins. RNA was always thought of as the intermediate, like the thing that's on the way to from between DNA, your genetic material, and proteins, the things we care about. That's how they've always been presented. But so there's messenger RNA, there's transfer RNA, there's ribosomal RNA, there's microRNAs.
Yeah, we learned all about that in 202.
Yeah, okay. So that's my specialty. And I use the computer to study RNA. And the cool thing about RNA is that so DNA is double-stranded, and you want it to stay the same because it's your genetic material, right? Like you don't want anything to come destroy it. So it's just kind of boring. It's double-stranded. It's always double-stranded. And then it, you know, wraps up to make, you know, around histones and things like that, right? For your chromosomes. But RNA is single-stranded, right? Like it's like spaghetti. And then it can take on all these different shapes. So like, just like a spaghetti piece can fold on itself and then fold again. And you don't have to have, so DNA has GC base pairs and AT base pairs. RNA has G and C and A and U instead of T. And so it can make base pairs, and it does that. But it also can have bulges where like there's a base that's not paired, or two bases that aren't paired. It can have loops where like 10 bases aren't paired. They're just free. It can have mismatched base pairs where like G and A can base pair. Isn't that cool? Like,
Yeah.
Anyway, so like really funky and weird. And then on top of that, beyond G, C, A, and U, there are these non-standard base pairs, and they're naturally occurring, and they're in every organism. And they're like little addenda, like little pieces of organic chemistry that are stuck on the A, G, C, or U. And they're called modified bases. And so one of my specialties is making computer models to model those non-standard bases in RNA.
Wow. So for students who would want to get into research labs, what advice would you give them?
So it usually starts with writing an email.
Yeah.
So I guess I should back up. It usually starts with like looking at a professor's website. So you like go look at the website and look at what they do and try to understand some piece of it. Something. You're not going to understand everything, but something. Pick something you like, and then maybe read a paper if you can. I know it's really hard to read a paper, but try to read the paper. Try to understand a little bit about what the professor does. You're not going to understand everything. I had to read my first paper 10 times, and that was just the intro to like get the idea, you know? So read a paper and then email the professor and say something like, "Dear Professor so-and-so, am a blah, blah, blah year student, blah, blah, blah major, and I would like to get involved in research. I went to your website and I read this paper that you published, and I just say one sentence about what you liked about it. I liked blah, da, 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 da. Just something that says you're interested in what they do, because professors love their research. And if you ask them what they do for their research, they're going to go on and on and on and on and on because they love it so much. And so if you say something, right, you want to work with them on their research. So you want to say something complimentary.
And sound interested and like know the basis of what they're talking about.
Because a professor, Stony Brook's really big. So that's the trouble. Normally I would say, you just write that email and say, can I please set up an appointment and, done, sort of thing. But a lot of professors need more than that. And so, so applying to multiple labs is important, like maybe 3 or 4. Between sophomore and junior year, and between junior and senior year, there are these programs both at Stony Brook and across the country where you can apply to get paid to do research over the summer.
We actually had a similar program. It's called Onward. It actually runs at Stony Brook, and a couple of students from your class, I was one of the students who were, we were supposed to go to Israel and do research at Tel Aviv University, and then that got canceled because of COVID. So hopefully we'll do it next summer.
Okay.
So
good.
They assign us to like a professor at the school and in a lab, and then we work there for 2 months.
Excellent. That's awesome. So on my website, one of my pet projects, I used to be director for the Office of Student Research at Truman State University. And so I just try to find research positions for students. So I have, part of my website has a whole list of different off-campus research experiences.
Would it be okay if we link your website like on the YouTube video on the description?
Sure. Yeah. And then usually you have to start thinking around December. And then the application deadlines are anywhere from December to February, with notifications March and April. So that really means, you probably should back up, maybe November, because you have to ask for letters of recommendation.
For to get research, you need.
Yeah, you need 2 letters of recommendation for the applications.
Okay, cool. So we wanted to ask you, what was your most interesting or unique experience that has happened in the lab?
There was the time I spilled radioactive material on myself. That wasn't good. That was not good. It was really good that I was in the lab on a Saturday, and I was putting away tritiated amino acid and into the waste container, and the shield in front of me fell on me and spilled the radioactive material on me.
Wow.
And
So what was the process after that? How did you have to clean it off?
I had to stand in one place, and I had to yell to my lab mate, who was also, because you have to have a partner, that's why you have to have a partner. So I said, hey, I spilled radioactive material on myself. Can you go get our professor? So he went and got my professor, and the 2 of them came in. And so tritium isn't bad unless you swallow it.
Oh, okay.
Okay, so you're fine.
Yeah. Well, except that you also don't want to track it all over the place.
Well,
so the 2 of them had to help me. I actually had to change into a different outfit and put all the stuff into a radioactive waste container. And then I had to clean up all the stuff and make sure that it wasn't radioactive. And yeah.
Yeah, that sounds tough.
Okay, so with the semester just beginning, do you think that colleges made the right decision by putting larger classes online?
Absolutely. I mean, I think it'd be really hard. You'd have to have you know, for that class of 570, you'd have to have classes of 50 in Javits.
Yeah.
You know what I mean?
Yeah. Like I've seen
So
already a couple schools shut down. 2-3 schools in New York already shut down.
yeah, I know, it's really sad. I think that Stony Brook has done really well because we're all kind of used to having bigger classes, you know, and Stony Brook is it's cheaper than a lot of other schools. You know, if I was paying $50,000 for my education, I don't know that I would want all online classes.
Yeah.
Yeah. It's definitely made a lot of people rethink whether they want to pay for school if they could find, you know, information elsewhere.
Well, so the thing is that like taking a class is important.
Of course.
Yeah.
I don't know about you, but like I've been trying to learn languages. Have you ever tried to learn a language on your own? Like Duolingo or something like that?
No.
Oh, okay. I've done like 5 really bad restarts of like Spanish or French. You know, it really does. It takes dedicated time. It takes time management. It takes a lot of discipline to have to teach yourself all the material on your own.
I agree. That's why synchronous classes I think are better because you wake up at like, let's say 10 a.m. and you know you have to be in class. But when it's asynchronous, you try to push it, you keep on pushing, and then you never do the work sometimes.
Yeah, you definitely procrastinate more when you know that you could watch the video anytime rather than designated time. All right. So now we have our speed round. We're trying out a new segment called the speed round.
Okay.
So it's just to get to know you a little bit better. So, favorite food?
Lasagna.
Favorite movie?
The Godfather.
Favorite artist or band?
That one's a tough one. I'd say Joseph right now.
Favorite city you visited?
San Francisco.
Favorite number?
4.
4. Favorite sport?
Soccer.
Favorite holiday?
Christmas.
Waffles or pancakes?
Definitely waffles.
And last question, a horror movie or a comedy movie?
Comedy. I cannot do horror.
All right, so that's all the time we have for today. Thank you guys for watching, and we'll see you again soon.
Thank you, Dr. Nagan.
Thank you.